Hello my dear students, today we are going to start a new chapter. This is chapter number 8. The name of the chapter is Rolle's Theorem and Mean Value Theorem. So this is a very important topic for you all because from this topic you are going to get one question. So today we are going to discuss Rolle's Theorem. This is page number 247. Student Science Savita Sir. 247, chapter number 8. So first I'm going to explain the statement and then I'm going to explain the geometrical interpretation and finally the application. So Rolle's theorem states that if there is a function f defined in an interval, closed interval a comma b, this is called closed interval a comma b, then if the function satisfies three conditions, then we say that the function satisfies Rolle's theorem. Number one is the function must be continuous in the closed interval a comma b. For this you need not show anything because all algebraic functions, all trigonometric functions, all polynomial functions are continuous. Is that clear? The second one is f dash x. I need to differentiate the function. F dash x exists in the open interval. Please be careful with the bracket. This is open interval, open bracket a comma b. And the third one is if f of a, that means when you put the value of x as a, equal to f of b, then there exists at least one value of x, say c, such that f dash c equal to 0. So this is the statement of Rolle's theorem. So as you can see, a function will be given defined in an interval a comma b. What you need to do is you have to show that the function satisfies these three criteria. Number one, it is continuous in the closed interval, square bracket a comma b. Number two, f dash x exists. That means you must be able to differentiate the function in the open interval, open bracket a comma b. Keep in mind continuity in the closed interval and differentiability in the open interval. And if f of a equal to f of b, then there exists at least one value of x, say c, such that f dash c equal to 0. So this is the statement of Rolle's theorem. So now you can just pause the video for a second and just take the screenshot of it, and you can copy it in your copy. So moving on. So this statement is very important for you all. We'll be using these three statements to prove that the function satisfies Rolle's theorem. Now let us try to understand the geometrical interpretation of Rolle's theorem. Geometrical interpretation means, suppose look at this, a function defined in the interval a comma b. This is your x and this is the function value fx. So let us say this is the curve at the point A and let us say at the point B. At the point A, let us say the value of f is fa. That means this point is a comma fa, and the value of b, this is fb, this distance. This is FB, so this point is B comma FB. So it says that the 2 points A and B are the intervals if f of A is equal to f of B. That means this distance is same. This distance is same. Then between A and B, there exists a point, let us say C, such that at the point C, f dash equal to 0. F dash C equal to 0 means at the point C, there is a tangent which is parallel to the x-axis. So the tangent is parallel to x-axis. This is the geometrical interpretation of Rolle's theorem. Once again, I made a curve. You take a point A, find out FA. You take a point B, find out FB. If FA is equal to FB, then there is a point on the curve between A and B such that the tangent is parallel to x-axis. So f dash C means the tangent is parallel to x-axis. So this is called the geometrical interpretation of Rolle's theorem. Okay, moving on. Now we come to the important part, that is application. We come to the important part that is called application of the theorem. Application of the theorem. To explain the application part, I will be doing few questions from exercise 8, page number 254. First, we are going to solve few ICC questions. Okay, question number 6, subdivision B. Verify the condition of Rolle's theorem for the function fx equal to, this is question number 6, subdivision B. fx equal to log open bracket x square plus 2 minus log 3 in the interval -1, 1. This is your A and this is your B. Okay, one thing I forgot to tell you is when will you verify Rolle's theorem, the function must satisfy the three conditions and the final condition says f dash C equal to 0. That means I have to find a point C between A and B where the tangent is parallel to x-axis, and that point must lie between A and B. That means the interval is -1 and 1. So the answer which we get must be between -1 and 1. It can be -1, it can be 1, but it has to be between -1 and 1. So let us start. Now this is a log function, so I have already told you all log, algebraic, exponential, trigonometric functions are continuous. So what is going to be your first statement? The first statement is fx is continuous in the closed interval. And what is the closed interval? -1, 1. Statement number 2, write down the function first. Fx will be log open bracket x square plus 2 minus log 3. Now you must be able to differentiate this. Differentiation is easy. Remember what I told you? When you differentiate y, you get dy by dx, and when you differentiate fx, you get f dash x. So differentiating with respect to x. So what do you get? F dash x. Standard or composite? Log should always be with x. So assume this part as x. Differential log x is d by dx. Differential log x is 1 by x. But this is just an assumption. So d by dx of x square plus 2 minus differential log 3 is 0 because 3 is a constant. So what is f dash x, please? 1 by x square plus 2. Differential of x square is 2x. Differential of 2 is 0. So finally f dash x is nothing but 2x divided by x square plus 2. So I could differentiate the function. So what will be my statement? Exist in open interval. What is the open interval? -1, 1. So I can just tell you that this is an ISC question. Only instead of 2, I guess there was 3. Could be 2018. So just see the way I've done it. I'll just give you some time to just go through it. Okay. So exists in the open interval -1, 1. Next, I just need this value. So I'm going to just write this f dash x equal to 2x divided by x squared plus 2. I need this value. Okay. So next, okay. Now moving on, the third step. What you need to do is you have to put the value of x, that is a and b, in the function. So let me put the value of x as a. What is a? It's -1. So this becomes log -1 times will be 1 plus 2 minus log 3. So log 3 minus log 3 is 0. Similarly, f of b is 1. So log 1 plus 2 minus log 3, that is log 3 minus log 3 is 0. So statement number 3 says if f of a, that means -1, is equal to f of 1. We show that they are equal. It's not necessary that it always becomes equal to 0. It's just that we have to show that the values are same. So if f of a equal to f of b, then the statement was there exists at least one value of x, say c, such that f dash c equal to 0. Now this f dash which you see, we have already calculated from step 2. F dash x is 2x divided by x squared plus 2, isn't it? So we are going to put the value. So f dash c means just replace x by c. So what do you get? 2c divided by c squared plus 2 equal to 0. So c squared plus 2 goes up and becomes 0. So 2c equal to 0, c equal to 0. So this is what you had to show. That means the value of c must be between the given interval, that is -1 and 1. That is how you verify Role's theorem. So before I move on to the next question, let me explain one more time what you need to do. First of all, a function will be given, and an interval will be given. The intervals are a and b. You are going to use the three statements which I have already told you. Statement number 1, you have to say that the function is continuous. Statement number 2, the function, you must be able to differentiate the function. And statement number 3, you have to show that f of a equal to f of b. If these three criteria are satisfied, then only we get a point C where f dash c equal to 0. That is, f dash c equal to 0 means a point where the tangent is parallel to x-axis, and that point we are supposed to find, and that point must lie between the given interval. Is that okay? So moving on, let me do one more ISC question. This is question number 9. Question number 9. So it's fx equal to e to the power x sine x, and the interval is 0 and pi. So that means this is your a and this is your b. Again the question is same. You have to verify Role's theorem. I hope you understood. Use the three statement, get a value, get a point, and that point must lie between 0 and pi. Pi means 180 degree. So the first statement that you are going to write is fx is continuous. Fx is continuous in closed interval. Closed interval. What is the closed interval? The closed interval is 0, pi. Number 2, f dash x, differentiate. Before that, let me write fx first, equal to e to the power x into sine x. So what do I write? differentiating with respect to x. So f dash x is going to be product rule u into v. So this is your u and this is your v. So what is product rule? U d by dx of v plus v d by dx of u. So e to the power x as it is, differentiation of sin x is cos x plus sin x as it is, and differentiation of ex is ex. So what is common out here? E to the power x, e to the power x. So what do I get? Cos x plus sin x. So what can I write? Exist in the open interval. Exist in the open interval. And what is the open interval? 0 comma pi. 0 comma pi. So this is question number 9. E to the power x sin x 0 pi. Is that clear? Now moving on. So this is the second statement. I need this value, so I'll just write it out here. So f dash x, what do you get? E to the power x, yes, cos x plus sin x. Cos x plus sin x. Next. What is the function? The function is e to the power x sin x, and what is the interval? Is 0 and pi. So statement number 3, put the value of a first. What is the value of a? A and b. So a is 0. So e to the power 0 into sin 0. Sin 0 is 0. So 0 into anything is 0. So f of b is pi. So e to the power pi. We don't know the value of e to the power pi, but we know that sin pi is 0. So sin pi into 0. Sin pi is 0. So 0 into e to the pi is also 0. Please keep in mind that sin n pi is always 0. That means 2 pi, 3 pi, 4 pi, 5 pi, 6, everything is 0. So you showed that f of a is equal to f of b. So you know what you're supposed to write? There exists at least one value of x, say c, such that f dash c equal to 0. F dash c equal to 0. Now the value, I need the value from statement number 2. So f dash x is e to the power x open bracket sin x plus cos x. I need this value. So what do? I just replace x by c. So what do you get? E to the power c, yes, sin x plus sin c plus cos c equal to 0. E to the power c goes down and becomes 0. So I am left with sin c plus cos c equal to 1. Now using this value, I need to get the value of c. So this is how it is to be done. Just see. So you got sin c plus cos c equal to 1. So you got sin c. So this is 0. So sin c plus cos c equal to 0. So you got minus cos c. Bring cos down. So you get sin c divided by cos c equal to minus 1. What is sin c by cos c? It is tan c equal to minus 1. Tan c equal to minus 1. Now I need to convert this also in terms of tan so that I can get the value of c. Now as you all know that this minus 1, minus as it is, 1 can be written as tan pi by 4. Yes or no? Now you know that 1 can be written as tan pi by 4, but you cannot cancel tan and tan because there is a minus sign. So in order to remove the minus sign, what do? So just see, minus, to remove the minus sign, I'm going to use quadrant. Why pi? Because I want tan to be tan only. It's just that I need to remove this minus sign. So pi means which quadrant? The second quadrant. If I put a plus sign, the angle is going to be pi by 4 only. If I put a plus sign, then what do I get? Add sugar to the tan, the value of tan will be positive. That means I will get tan pi by 4. Do I want tan pi by 4? No, I want tan minus tan pi by 4. So this plus will not be there. So pi means the second quadrant. If I put a positive sign, tan will be positive, but I need negative. But if I put a negative sign back to the second quadrant, and in this quadrant only sign is positive, so this is going to be minus tan pi by 4. So this is how you remove the minus sign. So I'm going to write tan c equal to tan minus tan pi by 4 will be written as tan pi minus pi by 4. Tan and tan gets cancelled, so c equal to 4. This becomes what? 3 pi by 4. And doesn't 3 pi by 4 lie between 0 and pi? Because see, 3 pi by 4, 3 into pi is 45. So 5 3s are 15, 4 3s are 135. So lies between 0 and 180. So this is how you prove Rolle's theorem. The only difficult part could be this minus 1. Once again, see the way I did it. Minus as it is, 1 can be written as tan 45. That was taught in class 10 only. Now, in order to cancel this tan and tan, I need to remove the minus sign. So the minus sign, how did I remove? So I wrote pi in front because the ratio has to be tan. So either the sign will be plus or minus. If I put a plus sign, then this comes to plus tan pi by 4. That is what that I don't want that. If I put a minus sign, minus means second quadrant, minus means back to the second quadrant. That means only sign is positive. So since this is tan, so it's going to be negative. So minus tan pi by 4 can be written as tan pi minus pi by 4. Tan and tan gets cancelled. C equal to 3 pi by 4. That belongs to 0 and pi. So this is how you prove. This is how you verify Rolle's theorem. This one was question number 9, a very important question. It had come in the year 2005. So I'll do one more question. So this is question number 10, 11. And one question from the example. ISC question. Okay. Let us do question number 4, subdivision 3. Last question. Question number 4, subdivision 3. The function is given as fx equal to x open bracket x minus 3 whole square, and the interval is x is greater than 0, less than or equal to 3. This also means 0, 3. So this is your A and this is your B. So whenever you see a polynomial, what you have to do is you have to simplify the function first so that the differentiation becomes simple. So simplify this a minus b whole square. It's going to be a square plus 3 square is 9 minus 3 to the 6x. So open the bracket. What do you get? X cube plus 9x minus 6x square. So statement number 1. What do I write? Fx is continuous in closed interval. And what is the closed interval? Square bracket 0, 3. I must get the value between 0 and 3. Number 2, f dash x. That means differentiate the function. Differentiate this. So first write down the simplified form. X cube plus 9x minus 6x square. So please help me out. So what do we get? F dash x differentiating. So this becomes 3x square plus 9 minus 12x. So f dash x is 3x square minus 12x plus 9. So what do I write? Exist in open interval. What is the open interval? 0, comma 3. Just writing down the statements will fetch your marks. That's why I told you this is a short question. So this is how you find out f dash x. So I need this value, so I'm just going to copy that. F dash x is what? 3x square minus 12x plus 9. Now statement number 3. For statement number 3, you need not put the value of a and b in the simplified form. Put the value in the original equation. Much easy. So f of a, what is a? 0. Put it out here. So going to be 0 into 0 minus 3 whole square, that's equal to 0 because 0 into anything is 0. And again f of 3, so this is going to be 3 minus 3 whole square. 3 minus 3 is 0, 0 into 3 is again 0. So what did you show? That f of a equal to f of b. So if f of a equal to f of b, then there exists at least one value of x, say c, such that f dash c equal to 0. Again, what does f dash c equal to 0 mean? A point between a and b such that the tangent is parallel to x-axis. So f dash c equal to 0. What is f dash? Please tell me. 3x square minus 12x plus 9 equal to 0. So what type of equation is this? It's a quadratic equation, yes or no? So let me simplify this. 9 3s are 27. So how do you get 27? Minus 9 minus 3x plus 9 equal to 0. 9, 10, 11, 12, you get 12, isn't it? So what is common out here? 3x is common, so what do you get? X minus 3. And what is common out here? Minus 3. So x minus 3 equal to 0. So you get x minus 3 is common, or 3x minus 3 equal to 0. So from here x minus 3 equal to 0, that is x equal to 3. I cannot take this value because the point must lie between the interval 0 and 3. Whereas look at the second one, 3x minus 3 equal to 0. So 3x equal to 3, so x equal to 1. That is, x equal to 1 lies in the interval 0 and 3. Hence, what can you say? Rolle's theorem has been verified. That means I have proved that the function satisfies Rolle's theorem. So before I end today's class, I'm going to give you a few questions for homework. So please note it down. Page number 254, exercise 8. So you are going to start question number 3, subdivision 3. Then you are going to do question number 4, subdivision 2. Then you are going to do question number 5, subdivision 3. And final question is 8, subdivision 2. Thank you so much.